Today we're going to talk about compound interest. So before we jump into this lesson, if you are interested in seeing me actually fill the whole sheet out, I will link that video in the description. So interest, we've discussed, is either money that you get kind of as a reward for investing money in the bank, or it is money that you pay for the privilege of borrowing money from somebody else. So we've talked about simple interest, which is interest that is earned only on the original amount. And then today we're talking about compound interest, which is earned on your current amount invested. And we're going to do an example so that we can see what that means. So our example here says Carlos invested $1,000 in an account that earns 10% per year compounded annually. The word compounded is how I know this is compound interest. How much money will he have at the end of 5 years? So I made a table of values for year 0 to year 5. So in year 0, that's basically when Carlos went to the bank and opened his account. He put $1,000 in, he didn't earn any interest right away, he just went in, he opened his account. So after 1 year has gone by, on the 1-year anniversary of him putting his money in, he earns 10% interest. So I calculated 10% of his $1,000 by multiplying 1,000 by 10%. That means 10 out of 100% means per 100. So 1,000 times 10 divided by 100 is $100. So he had his original $1,000. He has his extra $100 in interest, which means he now has $1,100. Now, if this was simple interest in year 2, he would earn another $100 from that original investment. But this is not simple interest, this is compound interest. So you earn interest on what you currently have in your bank account. So Carlos is going to earn interest on his $1,100. So we found 10% of $1,100, which is $110. And when I add that on to his current balance, he now has $1,210. So he then earns in year 3 10% of that, which is $121, for a grand total of $1,331. In year 4, he gets 10% of that amount, which is $133.10, for a grand total of $1,464.10. And then in year 5, he gets 10% of that, which is $146.41. And when you add that all together, he has a total of $1,610.51. So his original investment was only $1,000. He now has $1,610.51, which means he has earned a total of $610.51 in interest. So our question here says, is this linear or exponential? So if something is linear, it means you are adding or subtracting the same number every time. So when we did simple interest, we were adding $100 every single time. But here I'm not. I'm adding 100, then 110, then 121. So we're not adding the same amount every time. If something is exponential, instead of adding or subtracting, you are multiplying or dividing by the same thing every time. Now, I tried taking 1,100 and dividing it by 1,000, and I got 1.1. So 1,000 times 1.1 is 1,100. If I take that and multiply it by 1.1, I get 1,210. If I take that and multiply by 1.1, I get 1,331. So since I'm multiplying by the same number every time, this is exponential. Exponents are all about ways of writing repeated multiplication. So I am repeatedly multiplying by 1.1, so it's exponential. Our next question says, write an equation that you could use to calculate the amount of money after n years. So when I take a look at how we're calculating the money, we're starting with $1,000 and then repeatedly multiplying by 1.1. So it's definitely going to involve $1,000 and then multiplying by 1.1. So to get my first entry in year 1, we multiplied by 1.1 once. When I did it year 2, we would have multiplied by 1.1 twice. So it would be 1,000 times 1.1 squared. And then in year 3, we multiplied by 1.1 3 times. So it would be 1,000 times 1.1 cubed. So the equation that I wrote is that my final amount A is $1,000 times 1.1 to the power of the number of years, because we multiply by 1.1 for every year that has gone by. Okay, our last question says develop a formula for calculating compound interest. Now this is a little tricky. We're going to have to really put our thinking cap on for this one, but I'm not expecting you to do this by yourself. We eventually are just going to learn how to use the formula, but we wanted to talk first about where that formula comes from. So A stands for the final amount. That $1,000 was Carlos's starting investment. That's called a principal in financial circles. So this would be my starting amount or my principal. Now the 1.1 actually comes from the interest rate. So 10% divided by 100 is actually 0.1. So this is 1 plus 0.1, which is the interest rate as a decimal, and then to the power of n. So our formula here is that our final amount, or the letter A, equals our starting amount, or the principal, which is our letter P, times 1 plus the interest rate, but it has to be the interest rate after it's been divided by 100. So that's 1 plus the letter I, and then to the power of the number of years, which is n. So the formula that we are going to be using for compound interest is A equals P times 1 plus I to the power of n. And you can join me in the next video if you want to do some examples on how to use that formula.